process of removal of oxygen for extraction of metals from their oxide ores. Oxides of potassium, sodium, lithium, barium, calcium, magnesium, and aluminium cannot be reduced by using carbon, carbon monoxide, and hydrogen because of their high affinity for oxygen. Oxides of zinc, lead, and other metals which are placed below aluminium can be reduced on heating with carbon, carbon monoxide, and hydrogen. Metals like potassium, sodium, calcium, magnesium, and aluminium can be obtained by using electrolytic reduction. During this electrolytic reduction, the metal will be obtained at cathode. Metals like iron, lead, zinc, and copper mostly available in their carbonates and sulfides. So these metal carbonates and metal sulfides initially converts into oxide forms. These metal oxides reduce using common reducing agents. Common reducing agents are carbon monoxide, carbon, and hydrogen. During the extraction of iron from its oxide, iron oxide is reduced to iron by carbon monoxide. Iron oxide is reduced to iron using carbon as the reducing agent. During the extraction of copper from its oxide, copper oxide is reduced to copper using carbon as the reducing agent. Copper oxide is reduced to copper using hydrogen as the reducing agent. Highly reactive metals can also be used as reducing agents, but when using highly reactive metals as reducing agents will release very high amount of heat energy. Oxides of low reacting metals on heating will reduce to form metals. For example, oxides of copper and mercury on heating reduce to form respective metals. On moving down in the reactivity series, the reactivity with oxygen decreases. Metals like potassium, sodium, calcium, magnesium, and aluminium can react with oxygen at room temperatures. Potassium can react with oxygen to form its superoxide in addition to oxide. Sodium on reaction with oxygen forms metal oxide as well as metal peroxide. Calcium, magnesium, and aluminium on reaction with oxygen forms their metal oxides. While moving down in the activity series, the reactivity towards water decreases. Potassium, sodium, and calcium can react vigorously even with cold water with the liberation of hydrogen gas. Magnesium reacts very slowly with cold water but can react vigorously with hot water to produce hydrogen gas. Metals like aluminium, zinc, and iron does not react with cold water or warm water but can react with hot steam. The metals which are present above hydrogen in the reactivity series can reduce hydrogen ions from the acids like HCl and H2SO4. Reactivity decreases on moving down the group in the series. Potassium, sodium reacts vigorously with dilute acids to liberate hydrogen gas. Calcium, magnesium also reacts vigorously but slowly with acids liberating hydrogen gas. Metals below the hydrogen in the series do not liberate hydrogen on reaction with concentrated or diluted acids. Concentration of ores, one of the principal steps involved in the extraction and isolation of metals. Most metals are found in nature in a combined state. Metals that are found in a combined state in the Earth's crust are known as minerals. For example, not all minerals can be used to extract metals. Only the minerals that have a relatively high concentration of metal and can be extracted in an easy and cost-effective manner are used for extraction. Such minerals are known as ores. For example, bauxite is the principal ore of aluminium. The metal is extracted from the ore after a series of procedures and techniques known as extraction and isolation procedures. The main steps involved in the extraction and isolation of metals from ores are concentration of the ore, isolation of the metal from its concentrated ore, purification of the metal. The branch of science and technology that deals with the isolation of metals from their ores is known as metallurgy. An ore contains a metal associated with another undesired substance like sand or clay. These undesired substances are collectively known as matrix. The process of separating matrix from an ore is known as concentration of the ore. It is also called dressing or beneficiation. An ore contains a metal associated with other undesired substances like sand or clay. These undesired substances are collectively known as gangue or matrix. The process of separating gangue from an ore is known as concentration of the ore. It is also called as dressing or benefaction. Metals can be concentrated from their ore using any of the following methods: hydraulic washing, magnetic separation, froth flotation, or leaching. The choice of the technique used for the extraction depends upon the differences in the physical properties of the compound of the metal present and that of the gangue. The type of metal, the facilities available, and the environmental factors are also taken into consideration. The name hydraulic means operated by the pressure created by forcing water or any other liquid. Washing ore with water is known as hydraulic washing. Gold mines make use of hydraulic washing technique. An upward stream of running water is used to wash powdered ore. The lighter particles of the gangue are washed away and the heavier ore is left behind. This technique separates the gangue from the ore using the difference in their specific gravities. It is also known as gravity separation. Magnetic separation is used when either the ore or the impurities in are magnetic in nature. For example, separating iron from its ore hematite. Froth flotation separates the gangue particles from the ore based on the fact that gangue is wetted by water while mineral is wetted by oil. The ore is crushed into fine powder and mixed in water. Then, collectors and stabilizers are added to the water. A collector is a substance such as pine oil or fatty acid which enhances the non-wettability of the ore particles. A stabilizer is a substance like cresol which increases the stability of the froth. The mixture is agitated with the help of a rotating paddle. This draws air into the mixture and froth is generated. The froth is then skimmed off and is dried to recover particles of the ore.